Alright, so I get the stuff off the printer, and this is the thing that's going to go on the top. And I'll put a link below for the person who designed this. And it's just a real simple little bracket. And you just, I don't have a phone handy at the moment, but phone just lays in here, and then you have plenty of room to put a USB cable and headphone cable on the bottom. And it'll just lay flat on the bottom like that. And then I also have this, which is a USB. I printed 2 of them just to be on the safe side in case one breaks. I don't have to wait for another to print out. But essentially, this is a USB header, and this just goes in here, and it pushes in. It kind of locks in place. Now, what we got to do before I can do anything with that is find 5 volts, and I don't think I'm going to find that, but who knows? So if not, we'll just use a linear regulator. So it's no big deal. So first thing, let's fire this thing up. And I'm going to try something new. I have a different multimeter. It's kind of cheap, but that one is stuck in front of the camera, at least until I can get a serial one. So I'm not filming stuff. Because right now that's, as you see, it's just, yeah, a video. Alright, so let's see what we can come up with. So I saw this wire here. Let me zoom down and I'll show you. And it shows here 2 CD board, which makes me think, and it comes right off this switch here, which makes me think that this may be power. So let's switch that over to CD. If we go here, we have radio. Let's go to CD, and let's see what we get. We get about 9 volts. So when we turn it off, we also, it's dropping. Let me short that out here. Yeah, perfect. All right, so there's a capacitor in there somewhere. So that's 9 volts. So what we need, because I'm not going to get too fancy with this, what we need is one of these. So we need a 7805. All right, so I think what I'm going to do is, we're going to get a little creative. All right, so here's this is going to be the regulator and the heat sink. And we want the fins to face upwards because we want it to radiate heat away from the transistor. When this is in the unit, it's going to flip, and then the whole unit's going to come up this way. So yeah, this is going to be going upwards. Now, it might be, if I put it here, I might be blocking that screw hole, but that's okay because we can just cut that post off. I'm not too worried about that. I could just take the connector off, bend the pins back, and actually feed this right into the board because it needs input, ground, and then it has an output, and then I can just feed a ground off the other side of the board and then off the output. So I thought the camera was recording, but it wasn't. So I pulled this little connector off, and I can actually now get a look at what the silk screening says. It's a RST, which I'm assuming is reset, ground. It says 8 volt and 12 volts. So the 8 volt is where we're getting 9 volts from, and that's because it's running off of AC power. I'm assuming when you're running off of 8 volt battery, you're going to be getting 8 volts. And it says 12 volts. I don't know if there's actually 12 volts running off that, but we don't need 12 volts. We need 5, so the less the better. So what I'm going to do is, instead of using that used one with the shorter leads, I'm going to use a new one with larger leads or longer leads. And that way I can mount the entire thing, because these can get pretty warm. And I want as much surface area connected to making contact with the heatsink as possible. So I'm going to lay this like this. Instead of standing it up, I'm actually going to lay it like this. And I'm going to bend the leads, because here, this is actually perfect. We have RST, ground, 8. If we turn this over, this is the input, which goes to 8, which is perfect. This is ground, which goes to ground. And this is the output, which goes to RST. Well, guess what? We're not using RST, so I'm going to cut the trace on the other side, run a wire over, and that goes to the USB port. So that'll be perfect. I'm going to put just a little bit of thermal compound on there. Look at that. It is perfect. All right, so we got 3 coming through. So the first one we said was reset or RST. We don't really know what that does. So where did I put my knife? We're going to get rid of this trace. And the reason I'm just slicing it is because A, this board is halfway across the bench because of the way the camera's set up. I really need to get that fixed. But in the new shop, hopefully, well, in the new shop, it will be fixed. And B, because I can't see, I don't want to just run a razor across the whole thing. So I'm just digging it out. Yep. No more connection. You know what? Let's just do this. Let's put this right back on there. So the middle is ground. This is not going to work right, but and yes, I know that's janky. I'm going to glue that in place. And then let's see this side. Let me zoom out. This side gets cut. Let's see if we have 5 volts. We have 4.84. It's not quite 5 volts. Alright, so I tested this one with the bench power supply, and yeah, it's doing the same deal, and that's just the way it is. And as luck would have it, that's the last 5 volt with long leads that I have. So we're just going to make it work for now. I'm going to put it in. I could use a 7905. I really don't want to do that if I don't have to. A 7905 is for negative voltage, and you can make it work. So I'm just going to put it in for now. These traces are starting to come up. Okay, so now let's solder wires to the back of this header. Alright, now since this is the back of the USB header, this side right here is the positive. Let's see if I can do this without melting everything. And no, this is not the ideal way to do it. The ideal way to do it would be to have this anchored to a board. But in case you haven't been paying attention, nothing we're doing with this project, or most of my projects, are ideal. A few dabs of super glue. Watch me be out of this stuff too. Oh, there you go. Once this dry, I'm going to let this actually go and dry. And then once it dries, I'm going to hit it with a heat gun. And we'll heat it up nice, and then I'll smush it in. But I want to let this super glue dry some. So while this is drying, let's figure out where we're going to actually mount this. I'm thinking I was going to put it, somewhere actually on the case, but just to keep things simple, I'm thinking the lid. And if it breaks, who cares? Because what's going to happen is this is going to go here. Yeah, I know, janky, but again, remember, garage. It's going to be falling off shelves, things going to be thrown on it, oil, everything else. Don't care, just want it to work. That's going to go there. So we'll put the plug right behind it. It's going to be on the underside. Because then there's this big hole here where the laser used to go. Right there. Alright, so I got this on here. It's screwed and glued. Yeah, it looks like crap, but again, function over form. I don't really care what it looks like. I just want it to work. And I still have to replace that regulator. But I'll deal with that at another time. Got to get all these wires soldered back on and get it back together. Alright, actually, before I do anything, let's bust this off. This wire, I looked at the other side and it says speaker ground. I'll spare you the time it took to reconnect all the wires. There really wasn't much to it. Everything was already marked on the other side of the board. Oh, and the other thing I didn't really mention, I was thinking it, but I didn't really say it, was before I put the regulator in here, the output of this that was going to the old CD player board was approximately between 8 to 9 volts, and then we put the regulator on there to drop it down to 5. In theory, it's supposed to be a 5. It's at 4.88 right now, but I'll fix that later. And the voltage, that's all well and good. Well, what about the current? I haven't really measured current, nor have I even looked into the circuit to even see really how much it's going to hold. However, I'm assuming that it's going to hold at least 800 milliamps to 1 amp, simply because it's got to run this board with like 3 ICs on it, plus 2 motors, plus a laser, or a LED laser. So, which doesn't really use much, but with all that, you get about 500 milliamps out of it. So I'm hoping that we can get, or I can get, at least, 800 to 1,000 milliamps out of it. That I don't know, and if it doesn't work out, I can pull it off something else, or pull it right off the transformer, or just not use it at all. But I was, voltages and everything. You do need to have current to back it up. Alright, so just tuck this in, and this is just going to crimp it here. I'm not going to be winning any awards with this. It just needs to be functional. Okay, so both speakers are working. Let's plug this in. Alright, it works. So, there we go. Just close that down and pinch it in place. This, fitting with the style of everything else, I'm leaving the tag on there. And we're going to just glue this on with the last little bit of glue I have. So if it gets covered in oil, if it falls off a shelf, I don't care, as long as it works. And even if it gets broken, whatever. That's the whole point of this. It's got a radio, it's got AM, FM. So here we go. Alright, so here's my other channel. As some of you may know, the one that got demonetized. And where is the volume at? Works just fine. Could even turn it sideways. So now you can watch videos. I'm not hooking up the USB just yet. Like I said, I got to figure out, I got to get another one of those regulators or find one that's going to fit. I don't want to just jump it with a lot of, actually, let's try this. There we go. Let's see if this works. Well, it says it's charging it. I'll dig out my iPod charger cable. I don't know where that's at, and see if it charges the iPod. I really don't want to screw up a phone. But, yeah. If you can't see, it is, in fact, working. Figures, I think I got a bad cable. Whatever. I gotta glue this lid down. So, there you go. You got any questions, comments, suggestions? Leave them down below, and I'll see you next time. Bye-bye.